Hey all, Shmai Pau. My name is Idna and today I'm going to be taking you through the HackTheBox Sherlock Salinebreeze 2. So Salinebreeze 2 is an easy malware analysis Sherlock created by Vivisghost, and we'll try and find it here. It's actually part of a series of Sherlocks. It's a follow-on from Salinebreeze 1, which is a very easy threat intelligence Sherlock. They both relate to the APT known as Salt Typhoon, and this follow-up takes the threat intelligence you found in number 1 that step further by tasking you with analysing a piece of the group's malware. I am going to attempt to walk you through this today, even though malware analysis is far from a specialty of mine, an area I particularly struggle in, but here goes. So the scenario. Your boss was so impressed with your research skills that you have been rewarded with a new task, malware analysis. Your mission is to investigate a piece of malware linked to the infamous cyber espionage group Salt Typhoon. They've been targeting critical infrastructure and it's up to you to uncover their tactics and techniques. So I am going to be using Pwnbox for this, which is a browser-based version of Parrot OS. So first of all, I'm going to be downloading the artifacts we need. So first of all, let's copy the artifact URL to my clipboard and let's get those downloaded. Okay. Alright, so we've got that here now. So we're going to unzip these. The password we can get from here. The password is always HackTheBox, but you can copy that straight to your clipboard here. And let's look at what we've got here. Right, let's move these into another directory actually. That's a bit better. Okay, so that those artifacts gave us two files, a danger.txt and a danger.zip. So this is because this Sherlock has got real malware in it. So what we do with these is, if we just have a look at that danger file, this is an additional warning saying you should not be running this on production systems. It should be an isolated environment, somewhere safe to open real malware. And it gives us another password to extract that second zip file. So we're going to do that. And that did not work. Why is that? That's a bit better, capital P. Okay, so that gives us the OneDriveD.ps1 file. Let's have a quick look at that file. Oh my god. And we can immediately see this has got looks like a PowerShell file with a PS1 extension. And there's a massive blob of encoded base64 data here. Massive amount of data here. So that is very likely some kind of binary data encoded as base64, something like that. We're going to be digging into that in a lot more detail, but first of all, let us go back to our first question and see what we need to do for the Sherlock. What is the name of the malware family associated with the provided file? So what do we all do as malware analysis people? First of all, when we have a new file, we grab the hash. So let's take that and let's put it into VirusTotal and see what comes out of that. So in our family labels, we've got PowerShell, Demodex, and Obfuscator. PowerShell doesn't sound like a malware family to me. Demodex certainly could be. Obfuscator certainly could be. It could be either of those. I think Demodex is the likely, seeing as we're dealing with Salt Typhoon, and we know from Salinebreeze 1 that this is the kind of thing they were dealing with. However, there's another way we can confirm what the answer to this is. In Salinebreeze 1, part of our tasks were to part of our tasks were to do some research on this threat actor from this blog here. Extract a lot of information about their tactics and techniques, and this blog was a big part of that. We'll be using this blog in this Sherlock 2. For this particular question, right at the end, there is a list of IOCs that I want us to refer to here. So if we grab that same hash and search in here for that hash, you see this line here. So there's no actual file, malware family name, but we've got here again Demodex, or PowerShell dropper. It is a PowerShell dropper, but Demodex does look to be the answer to this. So let's copy that. And we've got our first answer. What .NET cryptographic class is used to perform decryption in the script? So we know there is a huge blob of data in here. We need to skip around this to have a look at what is actually going on in here. So beyond that blob of data, there's going to be some commands to set to do with it. So I'm just going to skip straight to the end of that file. Here we can see what the actual script is doing. So what we're going to do now, we're going to start to pull this apart and try to explain what is actually happening in this script. And that will help us answer this question and also some additional questions later on. So I'm going to do this in a bit of a clunky way, but this is the way I am going to approach it. Let's open up a new text file and let's just start pulling in all the bits of information from this file. Right. So let's start here, because there's a command before which I can't quite get to from this at the moment without scrolling through all that data. But to start with, we've got this file here. So let's put this in. And let's figure out what it's doing. I'm just going to annotate each line and try and figure this out. So this is loading in the k variable, the first argument passed to the script when it runs, and padding it with up to 32, padding it up to 32 bytes with zeros. So it's string, padding with 0. Okay. I said I'm going to skip that first one, but it's already irritating me that I haven't started at number 1. So I will come back to this. Oh, I should have just gone back to the beginning. Right. So we know that $S is that encoded blob of data. So let's add that to our annotation. Oh my word. Okay, right. And back to the end of the file, let's grab the next part. So we're going to, each of these semicolons is a separator between all the commands. So let's just grab up to the next semicolon, which is down here. Oh, that didn't work. Seasoned malware analysis people are going to be laughing hard at my approach to this, but I just want to break this apart a little to understand what is going on. Why didn't that copy to my clipboard? A bit better. Right. So let's have a look at what this is. So this is saving whatever this is into $O, or to the O variable. So it's creating a new object. And what is that object? So first of all, it has piped this backwards. It is taking this base64 string from base64 into text, and that's the new object type. So it's saying new object, and then inside these brackets is the object type. So this is basically creating whatever this base64 is as the object type. So we can find out what that is, but I will come back to that in a minute. I'll carry on analysing this and then come back to that base64 because we will need that. So this is decoding the base64 string and wonderful. Okay, next up. Okay, so this is a short one. I don't know what is going on with my clipboard today. It is all over the place. Okay. So this is just adding a new property to that same variable. What is happening with my scroll? A new property with a key size. So that suggests it's potentially going to be something to do with encryption. Not a huge surprise there. So adds a key size property to the $O. This is the next part. Let's grab that. That goes to here. So this is adding the key property, and it is just getting the bytes of the K variable. So that is that first argument. So K variable to a byte array and saves it to the key property of the object. Yeah, okay, that works for that. So basically, whatever is passed to this script as the first argument is going to get saved in this property as a byte array. Next, we've got the IV. So this is looking very likely going to be something to do with AES encryption. Got an IV key and the data, and that is just saving 16 zeros as the IV. Not a particularly strong IV. So this next is to S0. It is converting from base64 that large string. So this base64 encoded blob is saved in S, and then this is decoding that and saving it into S0. S1 ends here. So this is taking that the binary data, or basically the data that was inside this into S0, and it is using the so sorry, I thought that was an S for a second. It's the O object here, so this is that looks like the encryption object. It's using that with the method to create decryptor and passing that data to it. So basically S1 is the decrypted data. S1, and then finally we have, that's where the magic happens. It is taking S1, convert it to a string and running it as a script. Okay, so that's pretty much what's going on. So we've got that big encoded blob. It's creating a decryption object, decoding it from base64, decrypting it, and running it. That's basically what we've got there. Okay, so we've got a reasonable understanding of what is happening in this script now. If we go back to the question, what .NET cryptographic class is used to perform decryption in the script? So we're pretty convinced it's going to be AES related, but the class is what's being populated here with these properties. So this is the object type that was being created. So this is what we want to find out the value of here. So let's just copy that. We can come out of this. Oh, sorry. And we just decode that. And here we got system.security.cryptography.aes managed. That is our .NET class. Fantastic. Okay, task 3. The key to decrypt the script must be entered on the command line when running the PS1. What variable holds that key? So if we remember, when we pulled this apart, the key was being saved in K, and that was coming from the first argument bit run when the script. So the key, basically the operator here runs a script and adds an argument at the end of that, which is then used as that decryption key. So the answer to this is stored in $K. It's looking for what variable holds the key. So $K. Wonderful. If only they were all as easy as that. What is the key required to decrypt the base64 encoded data? So we don't have this information. We don't know what somebody entered when running this piece of malware. Only they know that. Only they know that, and the people that did a lot of analysis on this. So this is one of those times where the previous Sherlock would have given you some insight into how useful some of the information is in here. And there's lots of blogs around this reactor and around this malware in general. This is linking out all over the place. But this blog does hold some information for us that could be very, very useful. I will say you could probably brute force that the decryption on that. It might take you a little while, depends what you got, but given some of the potential weaknesses we saw here with an IV of 0, and we're going to have a look at the key in a minute, you would likely be able to brute force it. But either way, I am certainly not going to read this out. This is linked in the hint to the question. You can find the key by researching the malware. Pay special attention to the insights shared in the trend microblog post from the first Sherlock Salinebreeze, as it holds crucial information. So in this blog post, we can keep on scrolling through. This gives us lots of information about the actor, their campaigns, and the malware that they run, and their TTPs. We can keep on going, and at some point there is a little section here that, based on our telemetry, we discovered that the attacker was using psexec to execute the following commands to install the Demodex rootkit. So we know we're dealing with Demodex. This looks very, very familiar. And that is the argument that is being passed to that. It's being run straight afterwards. So that looks like our encryption key. Let's give it a go. And it is. After decrypting the initial payload, a new PowerShell script assigns a variable to the variable creg value. What is that value? So now we need to take what we have learnt here and effectively replay it. So we could probably write some Python to do this. I'm not going to do that. I'm going to use CyberChef because I love CyberChef. And I'm going to make sure I use the correct one. Right. Before I jump ahead into that, I need to get that encoded blob of data out so that I can decrypt it. So let us think about how we can do that in Bash. We can, first of all, let's just open it up for a second. We want to take the first line and we want everything inside the single quotes. So we can probably do something like, probably shouldn't be doing this live without a little rehearsal, but so that's going to give us the first line, and then we want to cut on delimiter single quotes, and then we'll want the second field. That looks good to me. So let's save that into encoded blob. Why not? Okay. Let's just import that into CyberChef. Encoded blob. All right, so first off, we want to decode that from base64. Then we want to AES decrypt. We know the password 123, so we need to pad that out, don't we? So why don't we say Python 3 password at 123 plus and we want 20 zeros on top of that, don't we? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So yeah, we're going to want 20 zeros on top of that. Oh, not 23. Okay, so that should be our key. Oh. And it is CTF. Our IV was 32 zeros. Is that going to be right? I can't count. I think that's right though. Oh, I keep using the wrong clipboard. Unable to decrypt. What have I done wrong here? Oh, that is not a hex input. That is right. This is looking better. That is looking okay. Yeah. Okay. So there we go. That looks like more PowerShell. So we have decrypted that blob and we found another payload in there. So let's save that. Let's call that decoded.ps1. And let's put it in here. Okay, we've got decoded.ps1. It assigns a value to the variable creg value. What is that value? Okay, so we need to have a look at this again. Decoded. So we've got another massive blob of encoded data. We can keep scrolling through. So we've got some other variables being set here. SVC name, so service name, service group, service description, service DLL path, key value, more data. I mean, I could probably just grep for that value, but I may end up missing some things I want to see. I'm going to pause the video while this scrolls a bit through that. Okay, so that finally stopped scrolling through, and we do find our creg key, creg value, and another blob of creg data, and then the kind of this is what is going to happen with all that data that's being declared. So if we remember our question, it assigns a value to the variable creg value. What is that value? So creg value was just up here, and that is MIDI help. We're going to get into what this script is doing very shortly. The variable creg data is associated with binary register data stored as a base 64 blob. What is the SHA-256 hash of the binary data? So we want to find the creg data now. And creg data is just this here. So let's copy that out. And I want to echo that. Oh god, that's horrible. I don't think that's going to work, is it? Nope. Okay. that is more like it. Okay, so we're going to send that into base 64 and then get the SHA-256 hash. Alright, so that is the hash of whatever data is being stored in that variable. Okay, great, we got that one as well, nice. What is the name of the malicious service? So grep worked nicely for us there. We've already gone through this data a lot. Rather than scroll through all that again, I'm going to simply just look for the word service in here and see what this comes up with. Okay, so this is what is the name of the malicious service. So we're looking to find out what is set as service name. So let's grep service name and service name equals this MSMNP for HW. Right, we're starting to get some information out. We don't still really know what this is doing, but we will have a look at that. What is the full path of the malicious DLL? So we did see this when we were scrolling. Can I see it on the screen there? No, I cannot. So let's use that trick again. Let's see if I can just pull it straight out. I thought we might end up seeing a bit more than we wanted there. Service DLL path, that looks like we might be able to use that to help us out. Yeah, that's what we want. So that is the path of the DLL, and that is what the question is asking us for. Fantastic. What registry path is used to associate the service group, MS group, with the malicious service so that it can be launched by svchost.exe? So let's first find that MS group string. Okay, so that gives us service group. So let's find where that is used. And this is the path where service group is being set. Fantastic. Okay. Question 10. What is the line of code responsible for starting a malicious service after it had been installed? So we did see this right at the end of that script. So if we tail this, we can see this is what is finally after it does whatever it's doing up here, which we will dig into. It runs start service and then name, service name. And that's not right. Have I missed something? There's a semicolon on the end. Oof. Okay. Which Windows API does the DLL import to obtain the local computer name? Now, that's jumped a bit, and I appreciate I've also jumped a bit answering some of these before really doing the analysis of this script. So I'm going to do the same thing I did in previously where I made an analysis, and I'm going to start pulling this apart piece by piece to try and figure out what actually is going on. I'm going to do a slightly different method this time, and I'm going to take a copy of that and call it payload analysis dot text. So now let's open up in this tab we know you've got this big piece of data here, and I am not going to try and suffer through that again. So what have I just done? Let's just create a new SVC host data equals large encoded blob. This is why I took a copy of this. So now I can delete that line. Suddenly things are starting to become a bit more readable. So we can see large encoded blob, service name, service group, service description, service DLL path. So that is setting up some key components related to a service. We could have a look at what that first line was that I removed. What am I going on here? So let's quickly, before we do that, let's take that first line that I just removed from the analysis document and put that into its own file. So that's just going to be the blob, right? Yeah. And I want to, actually I can probably do the same thing I did before and just bash through my way into getting just the data we want. So now we want to cut on the delimiter single quote and the field 2. I think that's going to be right. Looks good to me. Let's base64.d that out and save that into svc host data.bin. Let's have a look at what svc host data.bin is. It's an executable DLL. Okay, so we've extracted that DLL. We want that for to have a, we'll start analyzing that DLL shortly, but first of all let's carry on and figure out what this stage of the malware is doing. Okay, so I can actually edit this now, and it's a large encoded DLL. Right, okay, so then we've got another blob of data here. Let's check my notes here. These are all setting variables here so far. So what is this second one doing? sreg data. I probably need to extract that too. That's a lot shorter. But let's put it out because it makes it easier to read what is going on in here. What line is that on? Why does that keep doing that? So that's on line 10. So let's pull out line 10. So put out 10 lines and just get the last one. There's probably another way to do that, but that's the one for me. Right, and again, let's do our cut on single quotes and the second field. We've got a base 64, pipe that into base 64 decode and save it into the, what was the name of that? sreg data, sreg data dot decoded. I don't know what it is yet, do we? So, right, so let's have a look at what sreg data is. That is just a blob of data. Right, so we are now here, so we can then delete this line again to make it nice and easy. Sreg data sreg data large blob of base 64 encoded data. Right. So we've got a service being set, some registry key information here that is also S, so I wonder if that's related to this. Creg key, Creg value, and another blob of data here. A bit shorter, we can handle that. I don't need to extract that so much. It looks like we've got a reset key, which is a particular class ID. So this is trying to so this is now decoding service host data into service host bin. It's decoding sreg data into sreg bin, creg data into creg bin. So these are all got the raw data in them now. Well, so it's doing a try catch, and if it fails, it's just going to bomb out. Assuming it carries on, it's now checking for a registry key with this path, with the name, and if it's there, then it stops. So that's a bit like a kill switch by the look of things. Oh my word. There's a bit of a sleep there. It's now looking for is there a service name already there. If there is, it will continue. It will get the service name. If that is nothing, it will try to stop it. It will then look for what that service is running and then try to stop that process. Okay, so it's going to look if the service is running already, and if it is running, it'll try and stop it and the process. It'll try and kill that process. This is looking to kill any modules that are running that DLL, that path. More sleep. And now this is going to write the DLL data into not exactly sure what that's doing there, but this is setting a so this is just setting some registry keys relating to the service and is what's happening to do with that service. So we've got the registry key value. Then we've got more registry keys being set with the creg. So that's the sreg, and this was set in the creg. So this is placing all of those in the registry. Now it's creating the new service name with the path path link into service host. It's got a description that was set in that variable earlier on. It's then registering that service in the registry. And then starting the service. So basically what this is doing is extracting all the encoded information, using that information for a number of things. It's registering a DLL, it's registering a service and linking that service to a DLL, and it's registering some other registry keys on that creg data. I'm not entirely sure what they were doing, if I'm completely honest. I'm guessing it's something that service relies upon being there. So that's pretty much what's going on this stage. So we know that this malware is going to be basically creating a service on that host, and bringing that malicious DLL into the equation. We've got that DLL and we do need to analyze it. So which Windows API does a DLL import to obtain the local computer name? So like I said, we've got that DLL now. So did we call it something relevant? Service host data.bin, wasn't it? So all right, so let's just so that I can remember, and let's bring this up into Ghidra. Right, as much as I definitely need Ghidra help, I don't want that open. Right, let's create a new project. Salinebreeze 2. Import a file. And it's the DLL. I knew I needed to rename that because I nearly missed it. Let's bring that across there. Okie doke, looking good. And so let's start analyzing that. Yes, I would like you to analyze it. So we've extracted our DLL. We've got a rough understanding of what that script is doing, probably enough just to get us by. And now we need to look into that DLL itself and try and find out what's happening with it. Once that has finished analyzing, we're going to start having a look at, so this is asking us which DLL to import. So we're going to be looking at the imports section over here. I'm going to pause while that continues analyzing. So that has now finished analyzing, and we can come over to our we can come over to our imports here. You can see it's just importing these three Windows DLLs. Kernel32.dll contains a lot of very standard Windows APIs functions, and we are looking for the one that retrieves the computer name. The API here, get computer name A, is a Windows API that does exactly that. So if we just copy that, and that is going on there. So in service DLLs, which function is typically responsible for being called by the service control manager to initiate the service? Now, all programs have a main function. With Windows services, there is a function that gets registered with the service control manager that contains the service logic. And that is called service main. If we look over in Ghidra, back in our functions here, we can see lots of functions being pulled. Some are pretty standard ones. Some of the ones that Ghidra doesn't know what they're actually called because it can only decompile things so far. So it's not going to be any of those. And here we have service main. Service main is the name of the function that we are looking for here. So that is that. Oh, service main. Inside the previously named function, there are two calls to sleep. One uses a variable argument and one uses a hard-coded delay. What is the value of the hard-coded delay in milliseconds? So I've zoomed in quite a bit to this, so hopefully you can see it okay. So we're in the service main function here in the decompiler window. Let's move this over a little bit. And I'm not going to go into any great detailed reverse engineering because I don't necessarily have the confidence to do that. But I am going to skim through what's happening here, looking for the information that we want. So first of all, it's just it's declaring a load of variables. We can see it's doing some comparisons there, and that is where it is calling that get computer name function that we saw earlier on. Scrolling through a little bit further, then we see our first sleep function call, and that is calling that from a variable, so that isn't the version of this that we want. We want the one that's got the hard-coded delay. So we can keep on scrolling through here. If we were analysing this DLL in great detail, we would pick all this apart, but I am not going to do that. So we can keep scrolling here. And I mean, we can scroll or we can search. Let's search. Okay, I think we were pretty much there anyway, actually. But here is the hard-coded sleep delay. So it's 10,000 milliseconds. 10. Excellent. So that is Salinebreeze 2 done. So that wraps up Salinebreeze 2. Thank you for sticking with me. It was quite in depth for an easy challenge, I think. I very likely could have done things in a better way if I was better at malware analysis. But I'm here doing this so that I can learn as much as anyone else. I really hope you liked the video. If you did, please like and subscribe and all of that kind of good stuff. Please do check out Sherlock's on HackTheBox Labs. There are hundreds of them. We release a new one every Thursday and they are all great. Thank you for joining me, and I will see you again soon. Diolch yn fawr.